So in this session, we will take a look at a few questions based on trains. Most of these questions are nothing but a basic application of the concept of relative speed. But before that, let us see what kind of questions are set on trains. A few problems based on identifying the time required to cross or overtake. What is given? The length, speed, direction of travel of trains might be given. And what do you require to find? We might be required to find the time required to cross or overtake another object. So, what is the distance traveled by a train in crossing a man standing on a platform? Let us understand by a simple visual. Let us assume that this is a man standing on a platform, and here we have a train which at present is level with this man. Now, when the train crosses this man, the distance traveled by the train is equal to the length of the train. You can see there. So, we can say the distance traveled by a train in crossing a man standing on a platform is equal to the length of the train. Now, it's not necessary that train is crossing only a man. It could have been a pole also, or it could have been any object which is basically has a negligible length. In the next visual, we will see what is the distance traveled by a train in the process of overtaking another train. Again, let us see a visual. This is your first train. This is your second train. The first train will overtake the second train, and we will see what is the distance traveled. So you see there, the first train overtakes the second train. And what is the distance traveled by the first train? The distance is equal to the length of the first train plus the length of the second train. You can very easily identify both of these from the visual. Distance traveled by a train in overtaking another train is equal to L1 plus L2, where L1 and L2 are the sum of the two given lengths. On generalizing this, the distance traveled by a train in crossing a man is equal to the length of the train. Similarly, the distance traveled by a train in crossing or overtaking another train is equal to the sum of lengths of the two trains, and the distance traveled by a train in crossing a platform or a bridge is equal to the length of the train plus the length of the platform or the bridge, or as the case may be. Let us solve a basic question. A train 200-meter long passes a man standing on a platform in 10 seconds. Calculate the speed of the train in kilometer per hour. Now we know that the speed of the train can be determined by finding the distance that it has traveled and dividing that by the time. We know this formula. What is the distance traveled by the train in crossing the man? We have seen earlier that the distance traveled by the train in crossing a man is equal to its own length, that is equal to 200 meter, and the speed is equal to distance upon time. So 200 upon 10, 10 seconds is the time required to cross, and on solving this we get 20 meter per second as the speed in meters per second. Converting the speed into kilometer per hour, we have 20 into 18 by 5, that is equal to 72 kilometer per hour. So this is a very basic question of trains. Let us take a look at another question. A train 150-meter long running at 72 km per hour overtakes another train running at 60 km per hour in 90 seconds. Find the length of the second train. Again, this is a question where one train overtakes another train. So, the distance that one train takes to overtake another is equal to the sum of the two lengths. We have seen that before. So L1 plus L2, which is nothing but the sum of the length of the first train plus the length of the second train. Relative speed of the trains, because the two trains are traveling in the same direction. How do we know they are traveling in the same direction? Because in the question it is given to us that one train overtakes another. So it will overtake only if it is traveling in the same direction. So the relative speed is equal to 72 minus 60. When two bodies travel in the same direction, their relative speed is the difference of the two speeds. Therefore, 72 minus 60, that is equal to 12 kilometer per hour, which on converting into meters per second gives us 10 by 3 meter per second. Now, what is the time required by this train in overtaking another train? The time required is equal to distance upon relative speed. What is the distance? Distance is 150 plus L2, because 150 is the length of the first train. And what is the relative speed? 10 by 3. On putting the value of time, which is 90 seconds, is equal to 150 plus L2 divided by 10 by 3. Now this 10 by 3 into 90 is equal to 150 plus L2. On solving for L2, we get the value of L2 as 150 meter. So the length of the second train is 150 meter. But the most important thing that you need to realize here is what is the distance that the first train travels in crossing the other train, and why did we take the relative speed as the difference of the two speeds, 72 minus 60. If you understood this, the question would have been very easy to solve. Let us look at another basic question of train. A train 150-meter long traveling at 90 km per hour crosses another train running at 36 km per hour in 10 seconds. Find the length of the second train. Again, the time required by one train in crossing another is also the same, distance divided by the relative speed. Now, because these two trains are crossing each other, it means that the distance traveled by the two trains in crossing each other must be equal to the sum of the length of the two trains. So distance is equal to 150 plus L, where L is the length of the second train. Similarly, the relative speed in this case, because the trains are crossing each other, the relative speed must be equal to the sum of the two speeds, 90 plus 36, which is equal to 126 kilometer per hour. And when you convert 126 kilometer per hour into meters per second, you multiply that by 5 by 18 and you get 35 meters per second as the relative speed in meters per second. Now put the appropriate values in the formula. The time required is equal to the distance. The time required is already given as 10 seconds, which is equal to the distance, that is 150 plus L, divided by 35. And if you simplify that, you will get the value of L as 200 meter. So with this, we come to an end of this session on trains. If you have any feedback or if you have any queries, please feel free to contact us at studentservices@pfindia.com. Thank you. Thank you.